Hey guys, sorry, on 6.4 I missed percent error. So there's another, so this is going along with the percent increase and decrease. There's another thought here about percent error. Okay, so as you can see, percent error is the amount of error and the actual amount. Okay, so this is basically trying to figure out the percentage by which but that something is incorrect. So this is used a lot with car manufacturing. What was the car supposed to weigh? How fast was it supposed to go? How much fuel was supposed to go into the motor, as opposed to what was expected, or the actual amount. So when it says actual amount, this could be the amount expected. Okay, so we had a question about number 11, which is a good one to use here, I think, as an example. And note over here that the amount of error is always positive. So you can either overestimate or you can underestimate. You could have the exact same error, which we're going to see, whether you overestimate or underestimate. So that will make more sense if you continue to pay attention here. Okay, so let's look down here. So let's read the question. Let's zoom in a little. A researcher estimates, so this is their estimation, that a fossil is 3,200 years old. Using carbon-14 dating, a procedure used to determine the age of an object, the researcher discovers that the fossil is actually 3,600 years old. I'm adding a word here because that is useful. So they estimated 3,200, but actually, after using carbon dating, they found out that it was 3,600 years old. So first we need to figure out the amount of error that occurred. Okay, so that's always positive, so just like our others. So let's see here. Let's write so we have the amount of error over actual. Okay, over the actual amount or the true amount. Okay, so all we're going to do here is take 3,600 minus 3,200, and that's going to give us the amount of error that we had. And the actual amount is 3,600 years old. Okay, that's important to not get those mixed up, just like in the other one. Okay, so we end up with 400 over 3,600. We get out our trusty calculators. 400 divided by 3,600, and we get 0.1111111. 0.1111111. Repeating. Okay, now this again is the decimal, not the percentage, just like the percent change. So I'm going to move my decimal 2 places, and my final is going to be 11.1 repeating percent. Okay, so it would be A. Okay, now it wants you to think, and I want you to pause this if you've not already done this. What other estimate gives the exact same percent error? Remember, overestimating and underestimating are the same. Pause and check that, see if you can figure that out. Okay, so hopefully you got the correct answer, which is that this number right here needs to be the same. Okay, the actual amount is not going to change because that is what was found by science. Science found that 3,600 by carbon dating was correct, so you're not going to be able to change that. However, instead of underestimating with this 3,200, we're going to overestimate. So what amount over 3,600 would give me 400? And the answer is, drum roll, 4,000. Woohoo! 4,000 minus 3,600 also gives us that 400, which would be over that same 3,600, which is the exact same thing we have right here, and thus giving us the same answer. So explaining our reasoning is simply that whether you overestimate or underestimate by 400, you get the same percent error. All right, thanks. Have a good one.